Where do animals live and where do they roam? These important questions must be answered with accurate distribution and movement data to ensure conservation policy is effective. Tracking technology has undergone a revolution in recent years, both in the size of devices and the type and amount of data they can generate. This improvement in technology means devices have moved from being heavy collars which could only be placed on the largest animals to devices that are small, light, and can be placed on animals as small as a dragonfly. Tags don't just give information about animal movement either. Multi-sensor tags can tell what the weather is doing, the type of habitats the animal is in, interactions with other animals, and the behaviour and energy use of the animal. Tracking is now routinely used for fish, birds, mammals, and reptiles, and individuals can be tracked over many years. Where has tracking data informed policy and conservation? Some examples from the marine environment have been summarised in a recent paper published in the journal Trends in Ecology and Evolution in 2019 by Hayes et al. In this paper, the researchers state that whilst there remains a lack of direct links between animal tracking studies and policy, due in part to complex survey design, availability of data, and publishing timeframes, there are a number of examples where animal tracking data has been instrumental in developing conservation projects and initiatives. In the marine environment, animal tracking data has been used to help plan and manage marine protected areas, from where they should be placed to their size, and studies on how effective they are. Tracking data is often the only way to determine if a threat overlaps with a species range, so data directly influences fisheries management, helping to reduce bycatch, limit fishing areas, and inform quota management. In policy, a number of studies have informed species red list assessments and have been used to underpin the inclusion of species into the Convention of Migratory Species, which requires member states to take specific action to protect them. Some examples of these include tracking multiple penguin species, birds including petrels, and Antarctic fur seals was key in the formation of the South Georgia and South Sandwich Islands Marine Protected Area. Tracking data from wandering albatross, when overlapped with the movement of Patagonian toothfish vessels, highlighted where the bycatch risk was highest. Using this data, a closed season was implemented to reduce this risk. This resulted in a 10-fold reduction in bycatch rates. Elsewhere, tagging studies have shown how large roads restrict animal movements, if and how long it takes for animals to use structures such as green bridges, the effectiveness and use of protected areas, and much more. Identification of bird migration routes coupled with information on mortality rates along the route has been used to direct conservation efforts where the risk is greatest. On a more ecological level, tracking studies have uncovered unknown movement patterns within species, identified new subpopulations, and shown the individuality that can be present within a species population too. Real-time data acquisition has much broader applications, particularly for management practices on the ground, for example, where conservation ranges would be most effective within protected areas. Although the technological revolution is happening in animal tracking, there are still limitations to devices, meaning that a large proportion of species still cannot be tracked in real time. Websites such as movebank.org and myco.eco show animal tracking studies, mapping species movement across the globe, increasing data access. However, further collaboration between scientists, policymakers, and conservation practitioners is needed to ensure impact is maximised.